Probability of drawing three cards, and we are talking about dependent events now. The question here is, Tom randomly draws three cards from a standard deck of 52, one at a time without replacement, right? So when you don't replace, the number of cards decreases with every draw. Find the probability that the cards are drawn in the following sequence. The sequence is spades, diamonds, and red card, right? So there are 13 cards of spades, there are 13 diamonds. These are different suits, and the other two are hearts and clubs, right? And then a red card. So the cards could be red or black. Hearts and diamonds are red in color, and spades and clubs are black in color. So first understand your deck. A deck has 52 cards, 4 suits, 2 of them are red, 2 of them are black. The red ones are hearts and diamonds. The black ones are spades and clubs. And every suit has got 13. And those cards are ace, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and jack, queen, and king. So that is the set of 13 of each suit, right? So that is how you do and understand a deck of cards. Now let's go through the question once again. Tom randomly draws 3 cards from a standard deck of 52, one at a time without replacement. Find the probability that the cards are drawn in following sequence. Now as you can see, if you draw one card, the number of cards decreases, and these events are dependent. So the probability of this sequence is product of their probabilities, correct? So let's try to figure out how to get the answer for this. So we know one thing, the probability of getting spades is what? First probability of getting spades is how many cards are of spades. So there are 13 cards of each suit, right? As you know, spades also 13. So it is 13 over 52. Now what is the probability of getting a diamond? Now remember one thing, 52 I wanted to write, I wrote 50. So probability of getting spades is 13 over 52. Now the card is not replaced. We have already drawn one. So what happens now is that, so this is our first draw. Let me write this as our first draw. So let me write first draw, right? And now the second is, we are left with how many? We are left with 51 since one card has been drawn, right? So the probability of getting diamonds in a subsequent way, right, is total number of cards is now 51 with us because one was earlier drawn. So in the second draw, we have 51 cards, and diamonds is, there are 13, right? So we'll write 13 over 51 as the probability of getting diamonds. Now we have to get a red card. So the third card to be drawn should be red. Red means it could be diamonds or hearts, right? So in all, we have 13 and 13 of each kind, which is 13 plus 13 is 26. But we have already drawn one diamond, so we are left with one less than 13 plus 13. Do you see that? So there are 25 of red cards left. How many cards are left? One less than 51, that is 50. So that is the probability of drawing the red card now, correct? I hope you understand. Or let me do this math once again. So let's go through all the 3 cases one by one once again. So first one is, let's say we have a deck of cards and we draw the first card, and the first card we want spades. Since there are total 13 number of spades cards out of 52, the probability of drawing a spades is 13 over 52. Now we need to draw diamonds. We have already drawn one card, so this should be 52 minus 1. So that is 51, since we have already drawn one card. So we're left with 51. But there are 13 diamond cards, right? So probability of diamond card to be drawn at this stage is 13 over 51. Let's say we have drawn a diamonds card, whose probability is 13 over 51. Now in the third card should be red. Means what? Means that there are how many red cards? There are actually 13 of diamonds plus 13 of spades, 13 of diamonds and 13 of hearts. These are red cards. But we have already drawn one diamond. So we'll reduce that from here. And as far as the total number is concerned, it is 1 less than 51, right? 51 minus 1. Or you can say 52 minus 2. So that is how we get the number 25. So these are three different probabilities, right? As you can see, these are dependent events. So in case of dependent events, it becomes more and more difficult to get this sequence of cards. So the probability has to be much lesser than each one of them individually, correct? So we get the probability as the product of these, right? So we get product of getting spades, probability of getting diamonds, times probability of getting a red card. Do you see that? So we have individually found these to be 13 over 52. 13 over 52 can be written as 1 out of 4, right? Let me write 1 out of 4 here. So we'll simplify this. Here itself is better. 1 out of 4. There are 4 suits, right? So 1 out of 4. Diamonds 13 over 51. So that's a prime number. It cannot be simplified. So let me write down that as 13 over 51. And this one is 25 over 50, which is half, right? So that is the probability of getting spades, diamonds, followed by a red card. And how much is that? So let's multiply all of them. Numerator is 13 for us, and the denominator is 51 times 4 times 2, which gives us 408. So that is the probability of drawing diamonds, of drawing spades, diamonds, followed by a red card. I hope you understand how we got this, right? So as a practice, what you can do is, you can find probability of drawing this sequence where the cards are not being replaced. Let's say we start with hearts, and let's say hearts, and then we want a red card. Remember, hearts is also a red card, right? We take a red card followed by club. So club is black and hearts is red. Red card means if you've already drawn one hearts is one less red card, right? Keep that in mind. So what is the probability of 3 cards when you draw from a deck of standard 52 cards, one at a time without replacement, to get a sequence of a hearts, red card, and a card on clubs, right? So figure that out. So that is your practice question. Okay, let me call this as your practice question. Try to do it, and we have few more questions on cards, and then we will take up another topic. Thank you and all the best.